Assalamualaikum and hi, my name is Asra binti Khalid and my student ID is 2024289064. Okay, today I want to discuss about the differentiation. We know that the differentiation is same as the derivative. So I assume that derivative is fx with respect to x is the function of f prime x. And we also use the differentiation in our life, like in physics. The acceleration is the derivative of speed. So it tells how quickly the speed is increasing or decreasing. Okay, let's move to the question 1. For the question 1, I will explain about the meaning of differentiation and what are the technique of differentiation. So, the differentiation is a process in calculus to use find the rate of change of function with respect to one of its variables. In simple terms, it tells us how a small change in input x affects the output y. The derivative represents as the slope or gradient of the tangent line at a point on the curve. So it shows how quickly the function's value is increasing or decreasing. The derivative of function fs is written as dy over dx or f prime x.
Assalamualaikum, my name is Ayuni and my student ID is 2024802242. Now I will be presenting the techniques that we use in differentiation. The first and most basic rule is power rule. This rule is used when we are differentiating a variable raised to a power. Second, we have constant rule. It tells us that derivative of any constant value is 0. Third is sum and difference rule. It applies when we have the addition of or subtraction of two functions. Fourth, we have product rule. It used when two functions are multiplied together. Fifth is quotient rule. It used when we divide one function by another. Then we have chain rule. It used when we have function inside another function. Next is implicit differentiation. It used when we cannot isolate y easily and both x and y are mixed in an equation. Lastly, we have logarithmic differentiation. It used when we are dealing with complicated product, quotient, and function raised to a power. Now, I will be presenting my solution for question 2a. The function given is y equal to 3x squared secant x plus 2. To begin, we can observe that this function is the product of two different functions, which the first part is 3x and second part is secant x plus 2. Because of this, we need to apply the product rule in order to differentiate the function. The product rule states that dy over dx is equal to uv prime plus vu prime. In this case, the u is 3x and the v is secant x plus 2. Then we need to find the u prime and the v prime. For u prime is 6x, and to get v prime, we need to use the chain rule because x plus 2 is a function inside the secant function. So the derivative of secant is secant x tan x. Now, substitute all the value into the rule formula, then write it in a proper form, which we get dy over dx equal to 3x squared secant x plus 2 tan x plus 2 plus 6x secant x plus 2.
For the question 2b, first we need to identify the structure of the equation. We notice that this function is quotient, meaning it is a division of two functions, which is the numerator is u equal to 4x plus 2 and the denominator is v equal to cos x. Therefore, we will apply the quotient rule, which is the dy over dx equals to vu prime minus uv prime over v squared. Before we apply this formula, we need to find the derivative of u and v. For u, we know that u is 4x plus 2, so u is 4. While for v is cos x, so the v prime is negative sin x. After we got all the information, we can apply it to a quotient formula. It will become dy over dx equal to 4 multiplied by cos x minus 4x plus 2 multiply negative sin x over cos x squared. After that, we need to arrange the equation by change the negative sign to positive sign. So the final answer will be 4 cos x plus 4x plus 2 sin x over cos square x.
My name is Sofia Adriani binti Alias and my student ID is 202466742. For today, I will be discuss about question 3, which is to find the implicit for this question. So first, when we get this kind of question, we need to divide it to 3 parts. The first part is y ln 3x, the second part is e the power of 2x plus 1, and the last part will be tan for y. When we divide it to 3 parts, we need to differentiate each part. So for the first part, we need to differentiate y ln 3x, which is we need to use product rule for this question. So the u for this question will be y, and v for this question will be ln 3x. So when we differentiate u and v, we will get u prime, which is dy dx, and v prime, we will get 1 over 3x multiplied by 3, and then we will get 3 over 3x, and then we simplify, then the final answer will be 1 over x. After that, we put it into the formula of product rule, which is u v prime plus v u prime, and then the final answer will be y over x plus ln 3x dy dx. After that, we need to differentiate the second part, which is e the power of 2x plus 1. When we differentiate e, it will remain unchanged, but when we differentiate 2x plus 1, we will get 2. So the final answer of this question is 2 e the power of 2x plus 1, and the last part is tan for y. When we differentiate tan for y, we need to differentiate tan first, which is it will become secant 2 for y, and then we differentiate for y, which is we will get 4 multiplied by dy dx. The final answer will be 4 secant 2y dy dx. After we differentiate all of the 3 parts, we need to arrange them in the original equation, which is we will get y over x plus ln 3x dy dx, and then minus with 2x the power of 2e the power of 2x plus 1, and then minus 4 secant 2y 4 secant 2 4y dy dx equal to 0. So after that, we need to arrange the one that has dy dx at the front and the one that doesn't have dy dx at the back. So it will become ln 3x dy dx minus 4 secant the power of 2 4y dy dx equal to 2e the power of 2x plus 1 minus y per x. So after that, we need to factorize the one that has dy dx, and it will become dy dx ln 3x minus 4 secant 2 4y, and then equal to 2e the power of 2x plus 1 minus y over x. After that, we need to make dy dx as the main point, and then we need to arrange them at the back, which is the final answer. We will get 2e the power of 2x plus 1 minus y over x over ln 3x minus 4 secant 2 4y. So that is our final answer.
Hi, Assalamualaikum. My name is Damia Maisara binti Muhammad Faisal. My student ID is 20242288078. So for today, I'm going to explain to you guys about question 4, which is the linear approximation. Based on the question given, we need to change the equation to function in terms of x. So we need to substitute 80.99 as x. So when we let fx, the new function in terms of fx is root 4 x minus root 2 over square root x. Then we need to change the roots to power. So we will get fx equal to x power of 1 over 4 minus root 2 over x power of negative half. After that, we have to differentiate the fx to f prime x. So first, we will bring power of 1 over 4 to the front of x. Then the power will minus with 1. Then we will get power of negative 3 over 2. Next, negative 2 will be multiplied by the power of negative half. Then we minus negative half. With 1, we will get power of negative 3 over 2. So the results of differentiate is f prime x equal to 1 over 4x power 3 over 4 plus with 1x, 1 over x power of 3 over 2. As we can see, the value of x is 80.99, which we consider as the given values. The chosen value for x node is 81. Based on the formula for this question is delta x equal to x minus x node. So 80.99 minus with 81, the answer will be negative 0.01. Next, in this part, we will use the linear approximation formula. So we will just substitute all of the values in the formula given, and the final answer will be 2.778. Which already in 3 decimal places as asked in the question above.
After doing all of the assessment, we can conclude that it helps us to understand the basics of differentiation. We learn how to find derivative using different rules. For example, quotient rule, product rules, and chain rule. We also use implicit differentiation and linear approximation for solve problem. These skills are important for us to solve math problems about change.